So let's start with this weather briefing from February. Good morning again. Welcome. Today, Sergio, my colleague from Portuguese Met Service, is sharing with me this presentation. As you already know, some of you are coming many times, so you already know. You are welcome to ask questions and make comments. To do so, remember to press the button with the hand symbol in the upper toolbar on the top of the screen, and press also the lock button to speak on the upper left side. So you can use also the text chat. This weather briefing is being recorded and will be available later in the EUMeTrain webpage. So before I start with the weather briefing, just to check, as I like to know, just to check where are you coming from, and you can use star or nothing, anything else to say where you are coming from. Please do it. Okay, mainly Central Europe. My colleague from Azores also. Nice. Okay. I try to focus on many weather systems around Europe. Hope you find it interesting. Okay, fine. Let's move on. So let's start with an overview from 6 UTC today. And we have here the air mass RGB, height of 300 hectopascal, and also the mean sea level pressure in black lines here, and the 300 contours in blue. So you have here over the Atlantic, in this region over here, we have deep low with dense frontal clouds moving towards northeast near Iceland, and also you have over here this sharp and deep trough extending towards Morocco. And this weather system is very interesting because it's bringing cold air to the south, and also some stratospheric intrusion. And you can see it very well with this bluish and purple colors over here, and it's well seen here in the air mass RGB. So this is a cold air mass with a low tropopause. Also on this other side you can see up to the north, so this cloudiness here, so we have warm air that is bringing up to the north. Also interesting to see that, let's see if I can clear this. Okay, you can see here some fibers, and over Iberia you can see some lee cloudiness. So very interesting. This southerly flow is bringing some nice features over this region. Also here you have a surface high and this low pressure here, and we have some cold and dry air over this region. So both systems are bringing cold air to the south. And of course we have here some interesting weather system here with some vorticity maximum that I will show you later, and some convective cloudiness, and this warm air is going to the east over Turkey and Greece. So you will have some convective cloudiness during today. So from Meteor Alarm, we have here some warnings, mainly related to this area here of UK, some fog, and also here some snow related to that low system. And of course over here we have some thunderstorms, and here over Spain we have also some thunderstorms because of that warm and that trough over the Atlantic. So from EastFX we have here clear some thunderstorms south of Portugal and Spain, and some thunderstorms over this region related to that low pressure that I mentioned earlier. This is a product that I like very much. It's from NOAA. I just want to show you because it's a microwave observation from polar satellites, and it's a blended product. And it's very interesting to see how is the TPW evolution. And as you know, we have our responsibility also over here, Azores. So it's important to know how the TPW is behaving from the subtropical regions up to the north. So this is a very interesting product that here in Portugal we are using more or less to check the TPW evolution. Of course, during spring and autumn it's more important, but now you can see that we have some intrusions of high values of TPW. Okay, let's move on. So let's see the upper air dynamics. I use very much this image with also the simulated water vapor image from ECMWF that it's available on ePort. It's a way to check the model performance. So here it's possible to see this is the water vapor image. I'm not going to show you the simulated water vapor, but the moisture and dry boundaries and the position of the jet stream that's over here, and the areas of also dry descending stratospheric air associated to that deep trough with high potential vorticity. It's very well seen here today. Also, you can see, of course, as I was telling you, the jet. This is the isotext 300, and you can see here the jet, also a branch of the jet here, and another one here. Another way to check, of course, is to use the height where potential vorticity equals 1 PV unit, and you can see the dry intrusion over here with high values of potential vorticity. So it's a fine way to see the upper air dynamics, and a fine way to start to analyze the situation of the day. And of course, checking also the model performance. There is you can also use the night microphysics also at this time at 6 UTC, and to check with the low cloud cover from ECMWF. But be careful, because sometimes the model have problems with features like fog and very low clouds. So let's move on again with an overview. So again, the low pressure system, upper levels and low levels. Here another low pressure also upper and low levels, and the ridge over here towards the south, and of course this cloudiness that is related to this deep trough. So let's show you some nice features here with the temperature advection, and you can see this dipole of cold and warm advection. This is the occlusion, of course, and also here on this area we have this warm advection. It's related to this frontal system, and we have here a warm front shield because we have two maximum of warm advection. And of course we have here the cold front and somehow some warm conveyor belt in this area here, this region. This area here is very interesting to see that as some cold air cloudiness, so it's associated to a coma cloud, and this also here, and the cold air advection here at north associated to the high pressure, and cold and low pressure over here, and some vortex that's it's weakening around this area. And this area here with the jet streak, you can see that this region over Greece is somehow intensifying with because it's the position of the left exit region of the jet streak. So also the positive vorticity advection at 300 and 500, and you have the maximum here I was talking about earlier, and this weather system is rather severe, and also we have warnings in Greece, and remember Stoffek's issue level 1 warning. Some high values here of positive advection, positive vorticity advection here, and of course in all this region associated to the frontal system. So I want to show you some cross sections. I'm going to show you first this one here over Spain. So it's interesting to see these close lines here in the isentropes, and it means that we have a high gradient of isentropes with warm advection, these red lines over here, and we have a front. In this case, it's a warm front. Another interesting feature is this one here over Iberia. It's already in a occlusion phase. So we have somehow this V shape in the isentropes. So this one is over Iberia. So now I'm going to show you this pink one over North Europe. And this is more complex, and we can see that this area here, it's somehow with these close lines, somehow very stable here, but on the other hand we have here a region of some high gradient of the isentropes, and we have somehow some frontal system here. We can have we don't have to see, we cannot see very well this area here, but it's almost a V shape. I was showing you, it's almost a V shape, so it might be in an occlusion phase. It's very interesting to see this area of the gradient of the isotropes. Of course, the vertical spacing between the isentropic surface is a measure of the dry static stability. So that's why I'm saying this area here is somehow stable. And the last one I want to show you is the one over Greece, over this area. And it's also, we can see the slope of isotropes. So in this area, somehow warm front, this area some cold front, or at least some cold front-like feature. And the warm advection, I was telling you, this area, you can see strong warm advection in this area, and that's why we have some convective cloudiness along the day today. So now we are going to move to Sergio, that is going to present us an interesting case about heavy waves over the Portuguese coast. So I'm going to start with the synoptic situation of that day. It was on the 28th of January this year, and we have a situation of high waves over the Portuguese coast, and in this case we have to start some days earlier. So let's start on 25th of January. So here we have this low pressure system and this low pressure system, so both over the Atlantic, and this one here is the most important for this situation that Sergio is going to present. And it's at this time, at 25th of January, is still on cyclogenesis phase. It will be deep low in the next days. So on this right side, you can see the 10-meter wind speed field, where it is possible to see the strongest southwesterly winds around this slope. So you can see over here this red color of the wind speed. So very strong winds already at this phase. So 24 hours later, you can see this deep, intense, deep cyclonic vortex over the Atlantic. And the most important here for the situation is this large area of westerly strong, very strong winds over the Atlantic. Portugal is over here. Ireland is this highland here. So you see the big area over the Atlantic with strong winds during almost 3 days. On the 27th, we have here another low pressure is building up, and this one here is already is still a very deep low, but already with stationary phase. And you can see on the right side the intense winds, strong winds still over this region. And of course, the other deep low here with strong southerly winds also. So Portugal is in this region here. So pass to Sergio to start to talk about this situation of heavy waves, and a little bit different from the usual weather briefing. Go on, Sergio.
Thank you, Angela. Nice synoptic description about the last days of the January. First of all, good morning. As Angela said, my name is Sergio. I'm a colleague of Angela here at IPMA, and I will present some consequences of this strong atmospheric activity in the North Atlantic Ocean, and of course the consequences on ocean waves, especially at a small region, coastal region in Portugal called Nazaré. Well, I will start with some theory about wave storm life cycle. Well, you have the wind acting on the ocean surface, which means that there will be some energy that will be transferred from the atmosphere to the ocean, and to the area, as Angela said, that in this case was very large. In the surface of ocean that is influenced by the wind, we call it fetch. And here in this region we have only wind waves, which means there are short periods and irregular waves. But then this leads also to generate swell, which are the opposite of wind waves. There are long period ocean waves with well-defined crests. And of course you have the direction of the propagation of waves in the direction of the wind. The swell is mainly a function of the wind speed and of course the fetch area. So it's when you have strong winds and large fetch, you have conditions to have a huge swell in area and of course in intensity. Well, in this slide I bring here the wave storm generation and propagation from the point of view of the model, the European Central Weather Forecast wave model, with the resolution of a quarter of a degree from 26 here, 27 and 28 of January 2013. Here we can see that in 26 the waves are already at 10 meters, and 27 and 28 are clearly more than 10 meters. I would say at least 12 meters. These waves in the 28 are already swell. Okay, and you can see the movement of the direction of the swell. You can see here the three phases. You can see the generation at 26, just like Angela showed us. You can see in 27 propagation and of course approaching shore at 28. I would say at 28 you can see the propagation and approaching shore to first to the British Islands and after to Bay of Biscay and then the West Iberian coast. So we can easily see that the direction, the propagation of this swell, it's has a direction of west-northwest direction, which will be relevant to the results I will show at the end. But now I will bring you some results between by the synergy between the observations and the model. And by observations, I mean altimetry observations from JSON2 altimeter. This is the significant wave height product. You can see here the path of the altimetry. This is from 9 UTC 28, which was the last day. We have images that I show you in the earlier slide. You can see it in blue the altimetry data, in black the model. You can see some difference over here. They are, of course, strongly linked, but we're going to make a zoom in the next slide. Yes. So we will focus on our region of interest. That will be Nazaré. But here we have Portugal and Spain. You can see here in more detail the differences between the model and the observations, which is the WAM and JC2. You can see that in general, and in this case, you have the model overestimated in the more offshore areas, but near the coast, for instance here and also here, you can see that the WAM model underestimated, I would say, at least at 0.5 meters. Finally, we are in our region of interest, and you can see here more detail. You can see here more differences here. When you get this zoom, it's the difference between the model and the observations can be up to 2 meters. So especially here and here, well, Nazaré is located here, as I will show you, and all these points you've got here, they are spaced by 7 kilometers, which is the distance that the satellite travels in 1 second. When you get altimetry data, you have an information every second. So I think this might be a good example, a clear example, I would say, that altimetry products can, of course, increase the quality of the forecasts, but in this case I will say the quality of the nowcasting, maritime nowcasting, because the differences that can reach up to 2 meters are significant. This is why altimetry should then be used in an operational way. So approaching shore in the Nazaré Canyon, you have a canyon here, a canyon structure. Here you have the isobas, the mathematic of 200 and 500 meters. Well, and this is the Nazaré Canyon, which is an undersea canyon, and that ends in Nazaré Beach. And next we will look at this canyon from here, at the surface level. Okay. This is from the Portuguese Hydrographical Institute. This is the bathymetric. Here you can see this is land. This is Nazaré. I'll put here a star, Nazaré. And here you see the canyon. First, I show you here is the continental shelf. Here in the north, in the south also, and you have all these undersea canyon, The Nazaré Canyon is the biggest underwater ravine in Europe. It has about 200 kilometers, and at this region her depth is around 5 kilometers, which is quite impressive. This is a very complex system because you have, remember, the west-northwest propagation, and so the waves that will break in Nazaré will, of course, some of them will travel along the canyon. So, first you have here waves with, just remember, with between 6 and 6.5 meters in this region. We must remember the slow propagation. It was from west-northwest. And then you have the refraction process, which consists in the change of direction of propagation and occurs when the wave velocity changes. And the wave velocity is a function of depth, and you must have the waves will have a disposition perpendicular to the coastline. So this change of orientation relative to coastline as they move into shallow waters. So, but this is quite complex here because you have more process, not only the refraction process. You have rapid depth reduction and the positive interferences of waves. You can see the rapid deep reduction. For instance, here you see the isobath quite close. You can see, I think you can see. This is an overtopping of a topographical step, and that leads to a reduction of the wavelength and the high of growth. Simultaneously, you get this refraction process that I told you, and the loss of energy is minimum because you have the propagation is west-northwest. For instance, if the propagation was from north, the refraction will be a lot bigger, and so the loss of energy by the waves would be significant. But in this case, with this direction of propagation, the loss of energy is almost irrelevant here. And thus, yes, you have also the waves that travel in the Nazaré Canyon, which have more speed, and then there is a region where they met, and where the positive interference between these waves, between the waves that travels from the canyon and the waves that travels from the north of continental shelf, they meet. And so the situation over here at the end of the canyon, it's quite impressive, because you have almost all of energy in wave energy is here, because you don't lose energy by refraction and not by and also you have because the positive interferences, so you have lots of energy here. And as a consequence, on the 28th of January of this year, around 12 o'clock, the situation was like this picture. So, well, this is the end of the canyon that breaks in the north region of Nazaré, at 2 kilometers from Nazaré. That's when the Nazaré Canyon ends. And as you can see, this is a massive wave, a huge wave. Well, I don't know. I think that the image is quite. It speaks from itself. We can see here a surface. It is Gareth McNamara, who is already known to surface the biggest wave in the world. It's difficult to measure the wave. You can also always speculate about the wave height, but it's I would say at least around 20 meters at least. Of course, it has strong impact not only in the Portuguese media, in Portuguese newspapers and TVs, but also around the world. As you can see, the ABC channel, and also it appears, this photo, in the first page of the Times. And has a final remarks. If you want to come to Nazaré to see these waves, or even surfing, if you can also try, you should combine these conditions. You have to have a huge swell, which means the significant wave height values more than 5 meters. You have to have long period waves, not wind waves, long period, at least 13 seconds, no local wind, or west wind, which means wind from the coast. Well, that's all from me. I expect you have enjoyed.
Okay, thank you, Sergio. Very interesting, this case. Of course, we had huge, high, significant waves all over the coast, but of course in Nazaré we have this event, very, very interesting event in Nazaré area. We have finished for today. Just to tell you about the next weather briefing that will be on 19 March at 9 UTC by Lilian Offer and Andreas Wirth. I say goodbye, and we'll see you next month. And thank you for joining us in this weather briefing.